Thank you, everyone, for joining the webinar here. My name is Blake Standen. I'm the Senior Manager of Technical Sales at Brainbox AI, and I'm here with Josh. Josh, why don't you introduce yourself?
Hi, everyone. My name is Josh Mullen. I'm a Solutions Engineer at Brainbox.
Awesome. We're going to talk about, from smart to autonomous, pairing HVAC and AI to drive energy savings and reduce emissions. This will be a very introductory session into Brainbox technology and why we utilize artificial intelligence. And we'll kind of go through the reasons why we use it, what technologies we're using, and how they are impacting the current HVAC market. So the first thing is, from an energy engineering perspective, that's my background, and most others, commercial buildings need to reduce energy emissions costs and improve comfort. They consume so much of the building's energy, the world's energy consumption from a global perspective. And if you ever looked in a building and looked at the HVAC or any lighting or anything in the building, you know that there are improvement efforts that can be done with minimal cost and minimal effort. So the current challenges in the commercial real estate today is 45% of the commercial building energy comes from HVAC, and that's on average. And typically studies say that 30% of that is wasted because systems are designed to meet max temperatures or design day temperatures, and so they are over designed, and so they tend to run more than they need to. So we have some opportunity to save energy in those buildings. Current HVAC energy saving alternatives require deep retrofits. I would say, large capital expenditures for either an energy audit and a controls retrofit, or a replacement of a chiller, or redesigning an HVAC system. They're extensive and they have long timelines, and they take many years capital planning to achieve. Buildings produce close to 1/5 of the world's total carbon emissions. And so, 45% of that comes from, the HVAC system. So any reduction from a, kilowatt hour or natural gas reduction at the building level does reduce significant amount of carbon emissions from the grid and the power plants that are supplying that power. Another big thing in the world of HVAC is poor HVAC systems, lead to occupant complaints. So hot and cold calls are consistent, and they are relevant in every facility engineer's job. And they typically have goals to reduce those hot and cold call complaints. And so they focus a lot of effort on readjusting temperatures, trying to anticipate the thermal inertia of the building to reduce those complaints. So Brainbox, what we can do in a building and what we have done in a building is we have reduced carbon footprint by utilizing our technology. So up to 40% reduction in carbon footprint. And that's really going to be depending on the building and how efficient it is currently versus after Brainbox implementation. But we do cut back significantly on the carbon footprint. We have saved up to 25% in HVAC energy costs. So that includes kilowatt hour reductions, demand reductions, and so on in your net operating income. So depending on how building, efficient it is already, Brainbox on average is, 10%, 15%, depending on the building, but we have seen up to 25% on some buildings too. The big thing with utilizing AI, and we'll dive into a little bit more details, is the prediction element of the AI. If we know exactly how the building is going to run in the future, we could reduce the equipment runtime of the system. So when we reduce the equipment runtime of the system, it does increase life of that equipment, and you can reduce, CapEx needs or defer maintenance across longer term of the equipment, because it's going to last longer. And also, if we can predict the future space temperatures in the building, we can increase comfort. So we can reduce those hot and cold calls. We can anticipate the thermal inertia of the building as it starts to heat up or cool down throughout the seasons. So artificial intelligence is a buzzword. I'll be the first to admit it. I think most of my company would be as well. And so we need to really focus and educate the market of what is artificial intelligence or AI. So there are three levels typically when explaining artificial intelligence. So AI is the whole picture. So all technologies that enable computers to mimic human intelligence. So this could be, any regression model, any kind of calculation that's built into a computer could be considered AI. The next bubble below AI is really machine learning. So machines improve at given tasks with experience. So think of this as, the chess AI that is proven to be all humans now, because over time it learned and understood how the game is played, so it can calculate those scenarios faster than any human can. So that's the machine learning. So the newest form, I would say, over the last 10 years is this deep learning AI. And this really focuses on machines training themselves using different data sets and training themselves a lot faster using neural networks now, so multiple layers. And so when you utilize deep learning, you can train an AI model significantly faster, and it can be significantly more accurate with a smaller data set, in a quicker amount of time. So Brainbox is already, it's not reinventing the AI sector. So AI is being developed or used a lot in many, many different markets across the globe and across not just HVAC, but anywhere. So any chatbot that you see on a website is a form of AI. There's time series data that's predicting what's going to happen based off a time series, and that's really what Brainbox focuses on. There's translation, programs that translate. That's all AI driven, and obviously voice recognition is an AI technology that utilizes deep learning neural networks or recurring neural networks. So if AI could drive a car, why can't it drive a building? And when we build an autonomous car, Tesla, not us, they put a lot of sensors outside so they can understand what's happening outside and internally on how the car is running and operating. And it's using those sensors to predict what's coming as well. So understanding how that car is going to react as it's driving down the road and encountering new obstacles. So thinking about that and comparing it to a building automation system, and specifically an HVAC system, is that all the sensors are already there in an HVAC system. You have temperature sensors, humidity sensors, you have actuators on your air handlers, and all this data set that's already there. We just need to mix it with granular weather data, from cloud cover to position of sun, to humidity levels, and the prediction or the forecast of that weather too. And when we can mix those data sets, we can build a predictive model to make that building more preemptive and predictive and not reactive like current building automation systems are. So this is where I'm going to pass it off to my colleague, Josh.
Thanks, Blake. So Blake has presented the challenges facing the industry, how Brainbox fits in, and just a general overview of what AI is, what machine learning is, and what deep learning is. Before I go forward, we have a slide in place that is requested by our AI department as just a friendly reminder to ourselves every day and to everyone else that you can't just sprinkle AI on everything and all your problems will go away. That's not how it works. Machine learning is not magic. It's just beautiful math. And with that math, a lot of thought has to be, with a lot of forethought has to be done for data prep, how to normalize the data, data pipelines, how to get the data from the building to our cloud, to our models, from the models back to the cloud and to the building and right to the controllers. Lots of thought has to be put into that. Also data fidelity, right? And it's not enough just to do one use case. you have to make it scalable and robust. So we have entire teams dedicated to these divisions working every day to make it robust, more efficient, and better to enable these models to occur. The other concept that we have is that we try to apply machine learning to a broad selection of problems. Anything that will help us automate our solution, improve our QA, QC, and gets better over time, we try to apply machine learning to. And getting better over time is a big component of that, because machine learning only improves with more and more data. And then the client, on the client side, they see the impact by having certain models inform our algorithms and impart our commands onto the controls by pushing them into better operating regimes. And then finally, we're in more and more buildings. Sensor data and different types of sensor data, especially IAQ, is becoming more commonplace. So more diverse data is opening up different avenues to explore, be it CO2, occupancy sensors, dew point sensors, or relative humidity sensors in the space. So now I'm going to step into what Brainbox does by walking you through what we need for our models. So you need to think, a model is a model. So you always need an input, a select amount of inputs, and your desired output. And we use many different types of deep learning models and machine learning models. In the middle there's three examples or a few examples of different types of models that we implement to predict zone temperatures in the spaces, but we're not beholden to one particular type of model. It's more that whatever type of model gives us the best fit with the least amount of CPU time or effort, and it's robust, then we'll utilize it. And on the inputs, for this particular model, we're looking at predicting the future space temperature 1 to 6 hours ahead. What the inputs would be granular weather data. So we're incorporating third-party weather data that includes cloud cover, dew point, relative humidity, outside air, dry bulb, wet bulb, sun position, you name it. And then we're also incorporating and augmenting the BMS data that we're extracting from the building every 5 minutes on the air side, sometimes up to 1 minute on the water side. And that includes the outputs and the inputs of the individual level controllers. We also do a data cleansing process. So we do point normalization. We do haystack tagging, and we also associate what VAV boxes belong to what air handlers, belong to what chilled water system, what belong to what hot water system, so the models know what's going on. And all these inputs get rolled in to a model, and from that model, we send our temperature predictions over, and we decide, in this case, when to start equipment or when to stop equipment. So we make a prediction. Based on that prediction, our algorithms will know whether to write to the controller in order to enable our system to start up on morning warm-up or morning cool down, or whether to hold off for a bit longer because we know we'll be able to recover in time and we'll use less energy by doing so. So the big differentiator here is that there are lots of different analytics companies that use machine learning, deep learning, you name it. However, very, very few write back to the BMS and to the individual controllers. And then I guess so what do we need to write back? So in order for us to do optimum start or optimum stop, in this case, we would need the inputs of what the zone level temps will be, what are the energy data we create a bunch of virtual meters. What is the HVAC control inputs and outputs at this time? What is the occupancy schedule? So what is the true occupancy schedule of the space, not just the scheduled BMS schedule? Tariff structure, what is your utility rates? If there is any greenhouse gas emission intensity data, we'll take that into account as well in some applications. And then we have mechanical design information that is also informing those models. And from that, we will output commands to, the fan start stop, the fan speed modulation, the heating stage, the cooling stage, the economizer if available. On the VAV level, we're looking at space temperature set points. We never modified the occupied space temperature set points. We only use those as the boundaries to control and optimize to. And then for fan powered boxes, fan start and stop, reheat, we're looking at, the discharge air temperature set point to control the reheat modulation. Or at night, making sure that those reheats are closed and inoperable. And then finally, damper control, which would be coordinated with airflow set point. And then how this all works, for this instance, we are being preemptive instead of reactive. So a BMS system will have a lot of sort of hysteresis or a lot of overshoot of the heating and cooling. So if you think about this as a rooftop unit right now, it's going to start to cool the space down, overcool, turn off, a lot of wasted energy. It's going to drift some, and then it's going to bounce back into the heating set point and slam on different stages of heating. So we find it's more effective to do a preemptive approach. So if we know we will get to set point and not exceed set point by starting stage 1 of the heating component earlier, but create less of a demand and less overall energy draw throughout the day, then we will. And we'll start it preemptively and get up to space temperature set point, not overshoot and not create this waste where we're overshooting and heating and we're overshooting and cooling. And then we have many different modules that we're looking at and many different components of what we do. So we have models for temperature prediction or cooling or heating of a building, the cooling and heating loads. We have control optimization and making sure the commands that we're sending are true commands and that they're being accepted. We have power that we're looking to decrease overall demand and not create an increase in overall demand and power. Throughout the day and throughout the month, we have health metrics. So we're making sure that we have a heartbeat and that all our systems are being operated within the bounds that is defined by the client. So we're not causing excess heating or excess cooling in any space. Safety and validation. And what we're getting into more is community control or demand response. And Blake is going to talk a little bit about that as well. You're on mute, Blake, I believe.
Sorry, I'm on mute. So we went over a lot of, ways AI is informing data sets and utilizing a prediction of its unique building. So every building functions differently. Every building is built uniquely. System design is specific to that building, that construction, and that location. And so it's really important for us to utilize our AI to build a prediction model and to understand the unique thermodynamic nature of that building. So when I think of that, what else can I do with that future prediction? What else can I predict other than space temperature? And so we are utilizing and running scenarios and virtual testing and looking at other ways to utilize our future prediction for better control, significantly lowering energy consumption, keeping HVAC system efficiency up, increasing comfort of occupants and tenants, reducing the carbon emissions, and increasing building equipment life. So that is what we're currently doing today. And what Josh mentioned is we can utilize that future prediction for so much more as we grow in scale across, cities, across, electrical grids. The future is really bright for Brainbox AI. And now we're in our question and answer time. Julie or Josh, do we have any questions we want to answer?
You do have a question. It says, how do you calculate reference point to calculate energy savings? And how and when do you provide proof of savings to the customer?
That's an excellent one. Josh, you want to take this one?
Yeah, so during our discovery phase, we typically ask the client to provide at least 12 months of energy data. If they have interval data, that's even better. Typically, we're looking at the energy intensity or the energy utilization index in order to get a gauge on how the building is operating. Really efficient buildings, even if we can save, 5 to 15 to 20%, you're still operating with only a fixed amount of kilowatt hours to save and only a fixed amount of dollars or whatever monetary unit you're working in to save the client. On buildings that have a higher energy usage or a higher than average energy consumption, we know we can have a bigger and broader impact. And then we verify our impact in two distinct ways. One is after we have started to impart our control onto the building, we'll do a runtime analysis and we'll show the overall percent impact with respect to the HVAC equipment on, runtime reduction. So how many minutes fewer did the equipment run with Brainbox than without? The same as with chiller plants or boiler plants. And we'll also, if we have the virtual meters set up, we'll quantify the energy impact in a savings estimation range. We can't do true M&V on the second that we're deployed or 2 or 3 weeks in, because M&V requires a good amount of data to quantify the impact. But down the road, once we've been in a building and asserting our control for 6, 8, 12 months later, we'll be able to do a true measurement and verification in line with the IP MVP standards or ASHRAE 14 standards. Blake, do you have anything else?
No, that was very well said. Thank you, Josh. Julie, any other questions?
I don't see any in the chat, and I don't see any on the Q&A.
Yeah, there's.
Oh, wait a minute. There's two just came in. Sorry. Which BAS BMS systems have you integrated with so far with success?
Yeah, so I'll take this one. All of them that I know of. We utilize the open protocol called BACnet. So over the last, I would say 10 to 15 years, most manufacturers of control systems have standardized on the BACnet communication protocol. So the Siemens, the JCIs, the Trains, the Snyders, all of those companies have standardized on BACnet. So we have integrated to most control systems that utilize that protocol. We also have drivers to install in the Niagara Tritium environments that allow us a little bit more flexibility to communicate to older protocols. So we're also installed on those as well. We have, I think we're installed on all the manufacturers that I can think of off the top of my head. I'm sure there's some obscure ones that we are not.
Okay, and the next question is, what is the minimum duration of your service, and how do you calculate price of the contract?
That's a great question. So we are a SaaS model, so we charge a monthly fee. That monthly fee will be determined off, square footage of the building, how we're impacting location as well, because different energy markets and different locations have different, rate structures, and so on. So if there's a specific building in mind, we can definitely have one of our sales directors reach out to give you some budgetary pricing. But it is a square foot basis, and it is really inexpensive compared to a lot of capital improvements or large scale controls, upgrades, or even a retro commissioning project. Our service is well competitive and lower than those.
And then there's another question, Blake, about does our system only work in the cloud, or do we have on-prem options as well?
That's a great question. Right now, AI, our type of AI at the edge device is very difficult, and few devices have that kind of computing power to run the models at the edge. So currently today, our system does need to run from the cloud. We've built a very secure and robust connection method to the building that should meet all IP concerns from a security perspective. Happy to dive into that with further questions, but it does need to run at the cloud level.
Okay, you got it, Josh?
Yeah, there's we mentioned about inputs in your machine learning model. In an academic setting, can you take in classroom schedules? And the answer is, it depends. If they are a BMS BACnet schedule point, then we can take it in. If they're not, then we will coordinate with you for us to get that data in another means.
Absolutely. It like what Josh said, that type of scheduling system is very important. It changes often, and but there are programs that are currently out in the market that utilize this scheduling. I can name a few, but Brainbox is willing to work with any of those companies from an API connection perspective, or some way of getting those schedules into our platform.
Awesome. And that was the last question. I don't see any in the chat. Oh, wait a minute. You mentioned Haystack. What about Brick?
Josh, correct me if I'm wrong. We are not using Brick today. We're just using Haystack.
I believe that's right. I would have to defer to the mapping team, but yeah, we're mostly using Haystack.
I think we explored Brick, and it's a little bit newer protocol. From our perspective, we just have to normalize it to something. So right now, all of our algorithms and everything run off Haystack tagging and system. If a building had already brick nomenclature, the translation to Haystack should be relatively quick and easy and fast from our perspective, but we would translate it to Haystack.
Another question is, can your system work with the Microsoft Azure digital twin model?
We haven't tried yet. I know we've had multiple conversations with digital twin companies that could provide some outputs that would be interesting to our control and our AI models. But I'll be honest that those are future development and future testing projects that are probably long-term projects.